we're going to want to send eventually we're going to work up all the way back to Battleship, but here we're just talking at the very low level. How do you work with the serial object in Python? And I'm hoping by getting you to think here in the abstract, once we actually see the code here, that'll make sense. Sometimes when you dive right into the code, we lose the concepts. So we'll get to brass tacks in a minute here. But conceptually, what is the only thing you're allowed to, the serial port knows how to do is send bits, ones and zeros. So we're going to have to somehow, and we'll find in Python how it's done, actually send it to patterns of ones and zeros. Okay? So what you're going to write here are actual bits. And what you're going to read out are also just bits. Something like that. Okay? Now, that's kind of a hassle, right? We never have used bits before in Python, and you certainly, and we certainly do in MATLAB. Maybe you've done it in C, but we don't typically deal with an individual bit. We typically deal with bits in groups, in packs of 8. And that's just because the memory architecture of our systems are such, the CPU pipelines are built around multiples of 8. And so we'll always send bits in packs of 8. And in fact, serial is designed, well, you can set up in different ways, but 8 in 1 means send 8 bits at a time. That's 8 data bits, right? So we're going to send things in packs of 8. And do you know what a pack of 8 bits is called? A byte, yeah. And that's going to be kind of our fundamental unit that we'll work with. So we can send bytes of data back and forth across this serial port. Now we're going to quickly want to actually step up and send strings, right? Like text. That's what we're really going to want to do is send the text HELLO over this port. And how do I take something that's written like HELLO and convert that into a pattern of ones and zeros? Do we know that step?
It'd be like ASCII to hex and then hex to decimal, or hex to binary.
Okay, great. Yeah, so you mentioned ASCII. That's the key there, right? So there's a code, a lookup table that says, hey, for every letter essentially on the keyboard, on the English keyboard, we're going to specify a pattern of ones and zeros for that symbol. So the symbol lowercase h is represented by, and now I don't want to make this up, we can just, it's easy enough to find out what that representation is. We can just look for an ASCII table. Okay, and let's see, this is probably terribly small on your screen. Okay, I can look for the character lowercase n, or sorry, what am I talking about? Lowercase h. Okay, and we see that the representation for that is 68. So h is 68. Let me switch back to my... So you should keep this up just so you kind of are looking at it while I continue to talk. But h is represented as 68. Now I say that, but that's not ones and zeros. But I say it's the same. So what do I mean by that? That 0x68 is a representation in ones and zeros.
It's in hex, is that right?
It's in hex, okay, and the step from the h to the hex is a human just arbitrary mapping. You could come out, you could have done it a different way, right? That's called a encoding step. It's not so we'll talk later in the class about encrypting. We're somehow hiding information. Encoding is just changing the representation of that information. So we'll say that as long as you have the table, you can read the code either way. 68 goes to h and h goes to 68. So we're going to encode the H into this representation 68. Now 68 is equivalent to its binary representation, and that's an important distinction here. So let me show you what this looks like. Oh my, everything's collapsing. The matrix is falling apart. Okay. Did I? Oh. I'm sorry here. I didn't plug my machines in, so we're getting a bit of a falling apart here. But you see in Microsoft Calculator here, and if you'd like to, we can go over converting between hex and binary in more detail tomorrow, but I don't want to bore you if this is something you've seen before. So you can go to the programmer view. You see, usually you start in standard, but we can go to the programmer view, and then we get access to a slightly different layout where we can actually set our numbering system. So if I switch over to hex, I click the hex here and type 68, we see that can be represented, the same number, the same quantity can be represented in several different ways. And I find that hex is a particularly nice way. Like, why do I use hex, right? Computers don't use hex. Humans don't use hex, right? Why do I use this numbering system? It's because it is a compact way to represent binary data. Because every digit in hex corresponds to 4 digits in binary. So I can map the 6 to the first part of the byte and the 8 to the second part of the byte. So whenever I refer to bytes in a computer system, like a byte of memory, I'll use 2 digits to tell you what the value is. And there will be hexadecimal digits. Okay? Again, this is kind of hitting you fast with a lot of the low-level hardware topics here, but we need to understand these in order to build up our protocol stack, because the serial driver operates in raw bytes. We're going to actually tell it a specific byte to send, and it's going to send that single byte, and then it's going to be up to us to go to an ASCII table and to take that byte and say, oh, that's lowercase h, right? And then to put that together in a larger structure and say, oh, that's actually part of a guess, right, for a space. So we're going to take a text string, like the word hello. We're going to convert it using an ASCII table into its binary representation. And if you wanted to inspect what that binary representation is, what you'd see on a computer would be the hexadecimal version of it. And then we're going to send it byte by byte down the serial line. Okay? And depending on the baud rate, the 9600 setting, that can take some time. And in fact, it's going to take a lot of time from the computer's perspective. It'll take about several million clock cycles of the CPU, right? The CPU could have done a million other things, and then eventually the other byte comes through. Okay, so and I'll just close with this this slight modification to our read function. Let me pull that up in this window here. I said that serial.read, you can imagine it not taking any parameters. But what it'll actually take is the number of bytes you want it to read. But since those bytes take so long to come through, this will actually block and wait until you get however many bytes you wanted. So if you want to read 8 bytes, you can tell serial.read, hey, sit here and keep waiting and waiting and waiting until you've got 8 things, and then give them to me all at once. Right? Or 10 things, or 100 things. Okay? So the read will actually require the number of bytes as a parameter. And that is our lowest level view of how Python can communicate with other applications or other systems. So we'll pick up with this tomorrow in lab and actually start writing Python code to read and write data. We'll read and write to the tera term so you can see that it works. And then I will also try to get you set up with the serial hardware so you can read and write to somebody else or to yourself, but actually see it flow over a physical wire. Okay? So I think that's all the time we've got. And I will be happy to answer questions over email if there's something else. But I'm expecting then everyone to have the lab ready to go by class tomorrow, unless you've talked to me
So are we
separately.
submitting a screen recording again?
Yeah, although there's gonna be a gap in the recording because I had some issues, so I will post these up, and we'll talk through all this again tomorrow. I think hitting it twice is we might have to hit 3 times, but I'll post the screen recording. I do apologize. You'll see it's gonna be in two chunks. All right. Anything else?
For the lab submission, you want a screen record?
Oh, for the same thing as always. Please go through your code, show me what you've done, and run it a couple times. Show me that you're guessing. It goes back and forth, and try to get a hit, try to get a miss. And I guess actually, yeah, this is a. Sorry, I'm going over. If you can change the ship types at the top of player state just to a single destroyer. Like just put 2 up there in an array by itself, and then it's quite easy to win or lose the game. Right? You don't have to guess a bunch of ships. So feel free to change that value around while you demonstrate your code or while you're testing, in order to get to the win or lose state easier than guessing all a bunch of ships. All right. Okay, so there we go. I know I'm a minute over, but and my son says hello. But we'll talk tomorrow. All right.